Alright, so the orders that I got were Rodentia and Lagomorpha. Rodentia is pretty much going to be like your just usual typical rats and mice and squirrels and gophers, beavers, whatever, you name it. And then Lagomorpha is going to be more like your rabbits and your hares. So Rodentia is going to be the larger of the two, with about 2,277 species, which makes up about 42% of all mammal species. And there are some things that are pretty interesting about the rodents that makes them pretty unique. So there are 5 suborders, and each of these suborders are separated up into the specific layout of their masseter muscle, the skull shape, and the zygomatic arch. And so pretty much what these different formations do allow them to do, pretty much just allows them to gnaw. Gnawing is specifically unique to rodents, and as far as I understand it, from what I read, there's no other mammal that can do gnawing like they can. And so pretty much what gnawing is it's going to be the separation between the mandibular and maxillary cheek teeth. So pretty much what that means is, like, if I'm gnawing on something, I'm going to be using my incisors, and while I'm using my incisors, my cheek teeth cannot touch. Like, they have to be completely and totally separated, and vice versa. So if I want to grind plant matter with my molars or premolars, my incisors can't touch. They have to be completely and totally separated. And so that's what the layout and the combination of the masseter muscle, the skull, and the zygomatic arch do. The rodents will always have their incisors, and their canine count will always be 1, 1, and 0, 0. And since they have no canines, that allows for a really wide and a really big gap, the diastema, between the premolars and the incisors. And so that helps a lot with their gnawing. And so gnawing is unique to them because it allows them to do anteroposterior and transverse jaw movements, which pretty much means forward and backward movement of the jaw and left to right movement of the jaw. And so in order for that to work, the mandibular fossa and the squamosal have to be elongated, because that allows for the mandibular symphysis to loosen up, which allows for the transverse muscles to pull the ventral borders of the rami together, spreading the incisors or the premolars. And so the masseter muscles are very large, and they provide a lot of power for the movement of gnawing and mastication. And temporal muscles are usually going to be smaller than the masseter muscles, and this results in a reduction of the coronoid process. And so when you put all these together, let me back up. The incisors, obviously, if you're going to be gnawing, same thing for the cheek teeth. You're going to be grinding, you're going to be wearing them out all the time. And so a unique feature is that their incisors and their cheek teeth are ever growing, which means that they're constantly growing. and don't ever stop growing, which counteracts the wearing out of gnawing and grinding on the teeth. And so when you get all that together, you have a very unique behavior of gnawing, and over time, through evolution, the muscles in the skull moved from the back towards the front, and by doing that, it allowed for much better, more unique connections, the muscles that is, to connect to the jawbones in order to allow for those specialized movements that we see in gnawing. And so that formed a zygomasteric specialization, which took the placement of the medial masseter muscle, and moved it from the zygomatic arch to the side of the rostrum, by passing through the infraorbital foramen, and then these are the formations that make up the different suborders. And so that was one, and then another one is the lateral masseter muscle. Pretty much emerges or originates from the extension of the zygomatic arch and the medial masseter. It too will it'll emerge rather from the rostrum and pass through the infraorbital foramen, which reduces the temporalis and enlarges the coronoid process, which is pretty much the insertion of the muscle to the jaw, which allows for a better grip and a better connection. So one of the families that I'd like to talk about is the Sciuridae family. And the Sciuridae family consists of 278 different species of squirrels, chipmunks, marmots, and prairie dogs. And they have a pretty distinctive feature in their structural build, in terms of their skull. And that consists of the flattening of the flattening of the zygomatic arch, where the anterior part of the lateral masser rests in the front. And so that kind of just jumps gears. But one of the unique features of the Sciuridae family is of the flying squirrel. The flying squirrels have flaps of skin, if you will, between the forefeet and the hind feet. And pretty much whenever they jump from a base, let's just say for instance like a tree, jumping from a tree to a tree, when they spread those limbs out, it kind of just creates kind of like a blanket of skin, or a sheet of skin, allowing them to glide. And typically the squirrels can glide about 10 to 20 meters. But in some species, such as the southeastern Asian giant flying squirrel, they can glide up to 450 meters, and they can maneuver and turn however they want while they're flying, which is very unique and definitely something that not any other mammal can do. in terms of Rodentia and Lagomorpha. And so one of the species that has been of concern is the black-tailed prairie dog. Their populations have been declining as a result of a sylvatic plague, which is a disease that prairie dogs are more vulnerable to. Specifically that one. And so, since they're so vulnerable, it can very easily kill off a large amount of prairie dogs, especially within a colony, and usually kills about 99% of all prairie dogs in that single colony. So it's a pretty significant mortality rate. So the area of concern is obviously going to be the longevity of the prairie dogs. Mostly, not necessarily as the population of them as a whole, but the population of them locally. So just like a local colony or something, the extinction of that, which even in that of itself is a significant amount. And so, okay. And so that is a disease that is fairly unique to the prairie dog themselves. And as of right now, their IUCN Red List status is it's listed as least concern. So another family that I would like to talk a little bit more about is the beaver family, which they are the Castoridae family, and there are only two species, that being the North American beaver, which is the Castor canadensis, and then the other one is the Castor fiber, which is a Euro-Asian beaver. And something that's pretty unique to them specifically is how semi-aquatic they are. And normally, or in a lot of the species within Rodentia, they are fairly semi-aquatic in some species. However, none of the species have as many adaptations as does the beaver. And so I'm just going to go over some of those adaptations that they have. One of which are the hind feet are incredibly webbed, which allows for amazing swimming, and their tail is flat and wide, which kind of helps for stabilization or buoyancy in the water. And not only that, as you know, beavers are quite large, and they can roughly weigh up to about 30 kilograms. And their size is better for them. The bigger they are, the better, because it allows for heat conservation. So that helps with, like in winter months when the water is really, really cold. They need to retain that heat in order to maintain the right body temperature for their organs and everything to work and not shut down. And another way that they can conserve heat is through, they have an underfur, which is much more dense than their outer cover, than their outer coat, which is fairly waterproof, but not completely. But that underfur really helps with conserving heat. Another feature, this is where we start getting a little bit more complex. They have necessitating membranes on their eyes, which allows, it's a membrane pretty much that's like a third eyelid, if you will, and which can cover the eye while swimming and keeps it from getting gunky or dirty or, you know, any kind of dirt or any pollutant in the eye. So that's one. And then they've got a cool feature in their ear, which is kind of like a valvular opening, and it kind of just can shut the ear opening closed or open. So if it's swimming, it'll keep it closed, obviously, so it won't, no water will get in through the openings. And they also have that on the nostrils as well. So yeah, that was the beavers are incredibly vulnerable to tularemia disease. I wasn't able to find too much about that, besides the fact that I know that they're just incredibly vulnerable. So I think that that's one of those diseases that's kind of a little bit more unique to them. Yeah. So one of the things that I kind of found while doing this paper, or that at least I saw, was a lot of the rodents like to, or they prefer, or require, if you will, the dirt to be really loose, like really fine, kind of like a sand. And that pretty much, because a lot of the rodents are fossorial, and so they will dig like burrows for dens, in which they will that they usually stay in pretty much all the time, during the day, during the night, and typically don't ever go outside of the burrow to forage, really. If they do, they usually stay pretty close to the burrow. But back on the dirt, I found it interesting that a lot of the dirt that they prefer tends to be pretty isolated around hard dirt, and so that kind of limits and isolates the populations of whatever rodent it is, which can be pretty devastating for a lot of the rodent populations. But I also noticed that since they're looking for such fine and loose soil, is that oftentimes you'll find them burrowing like in the banks or alongside water, like water sources, so like streams or rivers or like ponds or something, because a lot of that soil is really saturated and really fine and loose. So let's jump on down to Lagomorpha. So Lagomorpha compared to Rodentia is going to be it's going to be significantly smaller, with only about 92 species compared to the 2,000 or so that Rodentia had. And this is going to be broken up into 2 families. One of the families is Acatonidae, which are going to be picas, which are going to be a little bit more similar to like hares. Let me double check that. That was wrong. So they're going to be a little bit smaller. So they're going to be more like, they're going to look more like mice. That was totally wrong. Look at me not knowing my stuff. But anyways, so they're going to be, they typically weigh around 100 to 150 grams, which is fairly small, especially for rodents. So something that was interesting to me that I thought was, that I didn't really see in any other kind of species, was the fact that they can pretty much just live just about wherever they want. Like Lagomorpha in general is just very adaptable and can change very quickly according to their environment, which is often a good reason for their widespread success. But like rabbits, they can inhabit a lot of different environments. And so if we jump down here to the Leporidae family, this one is going to be more of your hares and your rabbits. So these species, this is one of the species in which was very adaptable and oftentimes causes problems for a lot of different countries, because they can inhabit each of these environments. So they can inhabit Arctic tundra, mountain tops, like up the very top point almost, coniferous forest, deciduous forest, tropical forest, grasslands. So one of the species for the picas was incredibly endangered. So one of the species was incredibly sensitive to thermal changes, and was unable to move from its current habitat into a more suitable habitat, mostly because anytime it left the habitat that it was in order to get to the new one, it was pretty much a wide open area in which the temperatures were too intolerable. And so with this one and with a lot of other conservation efforts that I've seen for both orders, was just a lot of it was just a lot of land management and a lot of habitat protection. Like, no matter what the issue was for the animal being endangered or threatened or whatever, it was without fail, there was always something talking about, one of those land management, habitat protection, you name it. And that was one thing that I also didn't finish off with the black prairie dogs from earlier, is that once that disease was going around, they were kind of trying to figure out what it was, and so they did a lot of land protection and a lot of surveying of the populations, and that just made like such a big impact on a lot of those species. Is just managing those lands, keeping stuff from like cattle off of them, or other people even, or regulating like invasive species. And I don't know if that's necessarily like these things are specific to these orders, but that's just something that I noticed with each of these, because I did a endangered species and conservation thing for each family, and every single one of them without fail was just some sort of land management, typically something that was more along the lines of like a nature reserve, or like a national park or something that was either nationally run or run by some sort of government, in order to protect those species. And so a lot of times at the end of each conservation summary, it would just like list off all of the places in which that species specifically inhabited, like some sort of protected or private land, in order for proper management and surveying of that species. Another thing that was specific, that I think was a little bit more unique to rodents, where there were a lot of species in which they had really compact bodies, in which they would have things like short limbs, short necks, short tails, short ears, a small face or a flattened face, and are kind of just like little big fat balls with fur, if you will. And I just found that was really something interesting, that it was kind of just, without fail, there was always like a species in multiple species within each family that just had some sort of like compressed body feature. Awkward. There were a lot of species that were really well adapted for saltatorial behaviors, which saltatorial behaviors are pretty much being well adapted, pretty much means being well adapted for things like leaping. And in some cases, some of the species on here could jump like, I think it was like 6 meters or something in one jump, which is insane. And sometimes some of those species could even get up to 70 kilometers per hour, which is incredibly fast as well. So just a lot of there was at least one species in each family that was built for some sort of saltatorial behavior, and oftentimes that was combined with the fossorial behavior, which was the burrowing. And I think that might be something that's more specific to rodents themselves. And oftentimes that saltatorial features consisted of shortened body parts, like I was talking about earlier, such as like the forearms and like the head neck area, in which they could use the body functions, or reduce the body functions in those so that they could put them into like their back legs. So in cases they would have elongated elongated hind limbs and elongated hind feet. And that would also result in a very long tail that would help with balancing when jumping or leaping. And that was a feature that those were multiple features that came up almost with every single family that I had, and I think I had like about 35 families. So I think that's something that definitely stood out. Definitely stood out in Rodentia. So yeah, that's pretty much the gist of my paper. Took forever to write, but it was kind of interesting. I kind of enjoyed it, but whatever, I'm blabbering now, so I don't even know. I hope I'm not getting points taken off for just blabbering now. Yeah, I think it'll be alright. So yeah, I hope I answered all those questions for the mammalian order assessment and review. I think I did, but yeah, I'm just gonna wait until the camera shuts off, which should be any second now.